calculate the change in entropy when 50 kilojoule of energy is transferred reversibly and isothermally as heat to a large block of copper, first at 0 degree Celsius and second at 70 degree Celsius. So first of all, you will write some values for entropy change. See, write the process, then delta S system and delta S surrounding. So first is isothermal reversible, that is given in NCERT. Isothermal reversible, what is the value of delta S? It is n r natural log of V2 by V1, because Q, you know, nRT natural log of V2 by V1. So delta S is Q over T. And if it is isothermal and reversible, so you know, for such system delta U is 0. So heat absorbed by the system is equal to heat released by the surrounding, and in this way delta surrounding become minus nr natural log of V2 by V1. Yes, we can write P1 by P2. Now isothermal but irreversible. So if it is isothermal but irreversible, then delta S system is 0 and delta S surrounding is also 0. Sorry. Isothermal, any adiabatic let us, Q is 0, so that is adiabatic. So adiabatic reversible. So you know, adiabatic Q is 0, so delta S is also 0. Now adiabatic but irreversible. Because adiabatic reversible, Q reversible is 0, so delta S is 0. But when it is adiabatic but irreversible, then delta S system, it is equal to N CV M natural log of T2 by T1 plus NR natural log of V2 by V1. And delta S surrounding, it is 0 because it is adiabatic, it is not absorbed or evolved, only there is a change in, because it irreversible change, that's why there is a change in volume, change in temperature. Now isobaric. What do you mean by isobaric? Yes. So now pressure is constant, right? So when pressure is constant, yes, so it is n CPM natural log of T2 by T1, and delta S surrounding is minus delta S system. Now next is isochoric reversible. So what do you mean by isochoric? Okay, isochoric constant volume. So now it become n CBM natural log of T2 by T1, and it is again minus delta S system. So that you have to remember. Isothermal reversible, because isothermal means temperature is constant. So in that case it is NR. Actually you have to remember this equation. It covers both. So when temperature is constant, this part becomes 0. And in case of isobaric, pressure is constant means volume is constant. So again this part becomes 0. So it is n CPM natural log of T2 by T1. Molar heat capacity, and n is number of moles. So when we multiply by number of moles, so that becomes total value of Cp. Okay. So now come to the question. Calculate the change in entropy when 50 kilojoule of heat is transferred reversibly and isothermally. That means it is isothermal and reversible. As heat to a large block of copper at 0 degree Celsius and 70 degree Celsius. So that implies, sorry, isothermal and reversible. So it is actually NR natural log of V2 by V1, but temperatures are mentioned, right? So you know delta S is Q reversible by T. So now Q reversible is given to us. So Q reversible is 50 kilojoule, or we can write it as 50,000 joule. Now in first case, at 0 degree Celsius, delta S becomes equal to Q reversible upon 273. So it is 50,000 upon 273. So what is the value? Why we go like this? Because in this case V2, V1 is not given. N is not given.
So we don't have to calculate that, we directly know that.
Yes, because heat is given and just apply this second law of thermodynamics. Temperature is mentioned.
This comes out to be
1800 joule per Kelvin. Okay, and at 70 degrees Celsius it is 50,000 by 343, so it is 1500 joule per Kelvin.